All right, so now we're going to continue and do the section dealing with odds. All right, so let's think about an experiment like rolling a die. So if we're rolling a die is our experiment, then the sample space would be the numbers 1, 2, 3, 4, 5, or 6. Okay, that would be your sample space. And the outcomes of that sample space are all equally likely. Okay. Now, odds and probability deal with outcomes that are favorable to some event. So the experiment is rolling a die. The event might be something like, so this is the experiment, is rolling a die. This is your sample space. These are all the possible outcomes and they're equally likely. Okay. The event might be getting a 2. Okay. Then outcomes that are favorable to that event would be the 2. Okay. The 2 would be the outcome favorable, and all the rest of them would be the outcomes that are unfavorable. Then we can report the odds of getting a 2, the odds in favor of the event getting a 2. And the odds in favor of the event of getting a 2 would be 1 to 5, because there's one outcome that fits the event of getting a 2, and that would be 2 itself, and then the other 5 are unfavorable to that. So it's 1 to 5 would be the odds in favor of getting a 2. Okay. The odds against getting a 2 would be 5 to 1. So those would be odds in favor. And then if I flipped that and said 5 to 1, that would be the odds against getting a 2. Okay. So you're going to need to try to understand the difference between stating something using odds versus using probability. All right, so probability compares the number of favorable outcomes to the total number of outcomes. Okay, so the probability of getting a 2 would be probability of getting a 2 would be 1 out of 6. Odds compares the number of favorable outcomes. The odds in favor of an event happening compares the number of favorable outcomes to the number of unfavorable ones. Okay, so probability of getting a 2 would be 1 out of 6. So that's the probability of getting a 2. Okay. Okay. The odds in favor of getting a 2 when you roll a die is 1 to 5. See that difference? Doesn't even use the 6. Let's say. All right, so let's look at that. So this is hard. Sometimes things in symbols are hard to understand. So if the probability of some event happening, like getting a 2, is 1 out of 6, then the odds in favor of that event, in this case getting a 2, would be A, which is the same top number, 2, and then what this is saying is the total minus the number favorable. That's where the 5 would come from. Okay. So if the probability is 1 out of 6, the 6 is the total. The 1 is the number favorable. when you do odds in favor of that same thing, then this is still favorable. So it's that top number from the probability, but it's not to the total, it's to the unfavorable. And to get the unfavorable, you subtract the favorable from the total. Okay? Now, sometimes you'll have the odds in favor of an event. So if you knew the odds to start with were 1 to 5, what this formula says is to get the probability of the event, what you could do. So if the odds were 1 to 5, 1 is your A, that's the favorable outcomes. B is the unfavorable. What you could do is take the favorable, and to get the total down here, which is what you need, take the favorable and add the unfavorable to get the 1/6. So being able to move between probability and odds, you've just got to be thinking about those three quantities: the number favorable, the number of outcomes that are unfavorable. Those two together give you the total number of outcomes in your sample space. All right, so let's look at some of these. All right, here we got a spinner with the numbers 1, 2, and 3 on them. Each outcome is equally likely. And we're interested, so the experiment is spinning the spinner one time to get a number. And the event is going to be getting an odd number. We want odds in favor of getting an odd number. So since there's two odd numbers, those would be the outcomes favorable to getting an odd number. And we would say 2 to 1, okay? Because you could be a 1 or a 3. That's why we have 2 there. And then the one that's not odd would be 2. So this is your favorable number of favorable outcomes to the number that are unfavorable, which is not being odd. So 2 to 1. And then odds against, sometimes they'll have in favor and against. The odds against getting an odd number would be the reverse of that. It would be 1 to 2. Okay. Okay. All right, let's look at this next question. Anne is going to choose a single ball from a vase, an urn that has 4 balls in it. An urn that has 4 red balls, okay, 5 yellow ones, and 2 blue ones. We want the odds against each of the following events. So odds against getting a red one. So think about this. You've got 4 red, okay, in this vase. You've got 5 yellows, and you've got 2 blue, okay, in this container, right? And they're all mixed up. They're all equally likely. We want to know the odds against getting a red marble. So we're going to look, and we're going to see that the odds against getting a red marble would be 1, 2, 3, oops, I need one more Y. There's 5 yellows, 1, 2, 3, 4, 5, 6, 7. There's 7 that are not red to 4 that are red. So it'd be 7 to 4. That's odds against being red. So this is not red to red, okay? So the odds against being blue would be not blue. There's 2 blue ones. How many y'all total, right? That's 4 plus 5 plus 2 would be 11 total. So there's 2 blue ones, so that means 9 are not blue to 2 blue. So this is if we needed odds against each of those events. Okay. Now the probability against being yellow or, not probability, odds against being yellow or blue, okay, would be 4 to 7. Okay. So this would be not Y or B to being Y or B. Okay. All right, now just to kind of get you to think about it. If I wanted the probability of not being read, then that would be 7, but it wouldn't be over 4, it'd be out of 11. The probability involves the total here. Okay. We'll do some of that a little bit later. All right, here we have that the odds in favor of some event are 10 to 3. So these are the favorable to the unfavorable outcomes. If we want the probability of that event happening, then we need the favorable to the total. So it'd be 10, but it'd be over 13. We would get that, right? That would come from taking 10 plus 3, okay? The favorable plus the unfavorable give you the total outcomes. So that would be your answer. All right? Now in this one, we're being given a probability. And one thing that makes this one a little harder is that the probability we're given is a decimal. So it'd be nice if I could just write that as a fraction. So remember that right there, if we read it correctly, read it out, it would be 37 hundredths, since it's in that 7 is in the hundredths place. So that might help on that one, because then you can think of it as favorable outcomes, and then the denominator is the total number of outcomes. So if we want the odds in favor of E, we want the favorable first to not 100, but to the unfavorable. So we're going to take the 100 total, subtract the favorable ones. That's going to give us 63 that must be unfavorable. So this would be the answer to that question. Okay. Okay. If they had wanted odds against E, they didn't ask me for that, but if they had, and I started with this information, I would have gone and gotten the 63, and then I would have said 63 to 37. Okay, if it had said odds against E. Right, so you're going to have to work a little bit to make sense of that. Just remember the probabilities denominator is the total. Just remember probabilities denominator is the total. And the numerator is the favorable outcomes. And with odds in favor, it has favorable to unfavorable. Okay. And that these two add up. Okay. The sum is the total. That's the relationship. Okay. All right, let me just do one more example of that difference before I stop this one. All right, so just again, something kind of simple. All right, so let's switch back and forth between some probability and some odds in favor. So the probability of some event, and then odds in favor of some event. So if the probability of some event is 2 over 5, 2/5, okay? Let's do the odds. And then what if the odds are 3 to 7? Odds in favor are 3 to 7. See if you can fill in that spot for probability, okay? So if you're starting with a probability and you're needing odds in favor, then you should be thinking 2 is favorable, the 5 is the total, okay? For odds, what I need is, in favor, I need favorable to unfavorable. So I'm given the favorable, and then to get the unfavorable, I'm going to do 5 minus 2. So my answer would be 2 to 3, okay? If I'm starting with odds in favor of some event, then I'm thinking 3 is favorable, 7 is the number of outcomes that are unfavorable to the event. So if I want the probability of the event happening, I would take the favorable, but I wouldn't put it over 7. I'd put it over 3 plus 7 because it needs to be the total. So it'd be 3 over 10. So I'd be thinking to add those to get the total. And then the answer would be 3/10.